So we're looking right now at some very basic properties of radicals, and you might know some of these from previous years. We're going to review them anyway. So what we need to be able to do is actually to convert our radicals, so our square root signs, from one form into our exponential form. So we've got this important information here that says that if we have the nth root of some number a to the power of m, we can actually write it like this: a to the power of m over n. And that really becomes useful whenever we want to change actual numbers, or we want to be able to add or subtract exponents. So let's take a look at an example here. So we have the ninth root of 27 to the power of 3. So what does that become? That becomes 27 to the power of 3 over 9. Okay, 3 over 9 can actually be reduced. That becomes 27 to the power of 1 over 3. And we can actually switch back into our other format again. So I can switch back from my fractional exponent back into root format. So let's try doing that. So I have 27 to the power of 1 over 3. Well, that 1 is going to be my m, and this here is going to be my n. So let's rewrite it. I have the third root, because the 3 is my n, of 27, well, 27 to the power of 1, that's just 27. What's the third root of 27? That means what number times by itself 3 times will give me 27? So the answer to that is 3, because 3 times 3 times 3 is 27. Let's look at a couple more properties here. So for values of a and b that are bigger than 0 or equal to 0, this is true, that a, the root of a, times the root of b is equal to the square root of just a times b underneath the square root sign. So another example here, root of 7 times the root of 5. We can actually write that like this: the square root of 7 times 5, which is the square root of 35. Okay? And we can work in the other direction as well. So I could take the square root of 35, and I could say, well, that's the square root of 7 times the square root of 5. You can work in the other direction as well, and we're going to get used to working with that. We can do the same thing for division. So if I had the square root of a over the square root of b, or any root, as long as it's the same root, I would have the root of a over b. So one more example here, the square root of 8 over the square root of 2. Well, that's the same as saying the square root of 8 over 2. Let's reduce that. 8 over 2 is going to give me 4. And I actually know that the square root of 2, or sorry, the square root of 4, I ruined the surprise. The square root of 4 is 2. Okay, so we can use that sometimes to simplify and change something that looks very complicated into something that's much more simple.